Yeah, this should be live on Facebook now. I will go back and check again. Let's see. Can you guys hear me? Um Yawn, welcome. Benz, welcome. And so if you go to the best way to see the screen now is to go to YouTube and type the Jax tutor. Let's see if I can actually I'm gonna use this setup so that way you can see the screen entirely. Um Let me double check again on Facebook to make sure that everything is live. Yep, there you go. Now we are live on YouTube. Okay, all right, guys. So here's what we're gonna talk about. We're gonna talk about the law of sine. So here's what it's basically saying. If you give me two angles and one side in a triangle, I can name, I can tell you the value of all the other angles or all the other side in the triangle. And it's something that's very simple, and it's not a lot of work to do. It's very simple. But if you don't know how to use the formula properly, and one of the things that's going to happen is you will end up getting a lot of you will end up making a lot of mistakes. And one of them we'll see here a little bit. Ideal, welcome. Chapos, welcome. Okay, so go to YouTube and type the Jax tutor, and you'll be able to see the screen. All right, so law of sine. So what we're gonna do here is saying, and let me write the formula, and then I'll tell you what it really means. So what the law of sine said, if I need, and in this case, what am I looking for is so let's say I'm looking for this angle right here, right? So let's say I'm looking for the angle beta, and I don't know what it is. I'm looking for that angle. Heidi, hey, how you? Welcome. Jared, welcome. Chasey, welcome. So let's say I'm looking for the angle beta, and beta is what I'm looking for. I don't know what this angle is. So what I will say is the law of sine says that if I have the sine of the angle alpha, 35 degrees, and in this case, the angles are in degrees, divided by what? Divided by the side that is the length of the side that is opposite to this angle alpha. And what's the length of this side that is opposite to the angle alpha? And the angle alpha is here is 35 degrees. The side that is directly opposite to that is what? The one that 6. So sine of 35 divided by 6 is the same thing as, and we can continue to do this, Caden, welcome. We can continue to do this for all the other angles. So what I mean by that is sine of that angle divided by the side that is opposite to it is going to be equal to what we just put down on the screen. So I can do this for the angle beta, sine of beta, divided by what's the side that's opposite to beta is, what's the length of that side is 8, which is also the same thing as sine of this third angle right here. And I'm going to color code them. Let me color code these to make that a little bit easier for you. So I'm going to color code each one of them to make it a little bit easier to see. So I have the one alpha, angle alpha, and the sine in blue. Let me go maybe red. So this right here is the side that is directly opposite to the angle alpha. This side right here, I have it in red, which is 6. This is equal to sine of beta. Let me choose a different color for beta, maybe green. Sine of the angle beta, sine of beta. And I'll put in the angle beta here in green so you can understand what I'm doing, is divided by whatever side that is opposite to beta. And I'm going to color that in maybe purple. So divided by the side, that is directly opposite to this, which is this side right here in purple. And as you can see here, it's 8, whatever unit you're using, centimeters, meters. So now we have all of that set up, which is also the same thing as saying, sine of, and I'm going to write this third one in black because we probably won't use it. I'm going to write this in black. We won't be using this, which is also the same thing as saying sine of gamma, this angle right here, sine of that angle, divided by the side that is directly opposite to this angle, which is that side right here. And I could call this side, maybe if I call this side X or A, whatever I wanted to call it, and it would be the same. So all of those are equal. And to find the angle beta, all we need is the ones, we don't need this because we don't know what gamma is. We don't need this part of this equation. We don't need of that equality, I would say. We don't need this part of that equality. All we need is those three values. We can find sine of 35 in the calculator. We have this one, the side that is directly opposite to the angle that's 35 degrees, which is 6. We also have the 8, which is the side that is directly opposite to the angle beta. So now all we have left to do is plug in those. All we have left to do is plug in those numbers. So yeah, that's all we're gonna do. We're gonna plug in those numbers and see which one of them give us a value for, which one, where do we find a value for, what's the value for sine of beta. Now, here's what we're gonna do. So this is what we have in front of us, and we don't need the triangle anymore. And to recap, so what we did is we said the law of sine says if I have, two angles and a side, or two sides and an angle, I can find everything else about the triangle, about all of the sides, all of the angles. Nicole, welcome. Choke, welcome. Mary, welcome. So now, what we did, we started with sine of 35, which is this angle right here. And we said that divided by the side, the length of the side that is directly opposite to the angle that's 35 degrees, is the same thing as sine of this angle beta that we're looking for. Remember what we're looking for, beta. And I should probably color this in green because that's what we're looking for. Divided by the angle, sine of beta divided by the length of the side that is directly opposite to the angle beta, which give us what? Which give us 8. And this is the angle beta. Directly opposite to that angle is this side right here, which is 8. Now, we found all of that, and we know all of that. Now, all we left to do is finding the side, the length of the side, of finding beta. So how do we find that? And the easiest way to do that for me is cross multiply. So what I mean by that is I will multiply, and I'm going to need my calculator for this. I'm multiplying sine of 35 times 8, and I will multiply sine of beta times 6. So I'm going to put everything in the same color. Since I'm using green right now, I'll write sine of beta first. But this sine of beta gets to multiply by 6, which is in red. 6 multiplied by sine of beta. And I color code them so you can understand what we're doing, is equal to 8, which is in purple, multiplied by what in blue, sine of 35. And we didn't do anything magical about this. So we just cross multiply. We'll multiply this guy by this guy. We'll multiply this guy by this guy. So now, Kat, welcome. Nikki, welcome. Samantha, welcome. David, welcome. Yanjis, welcome. And so we didn't do anything magical. All we did is cross multiply. So what we can do here is to find the sine of beta. We can divide both sides of this equation by 6, correct? So how do we do that? We divide this side by 6. And also we divide this side by 6. So let me put this in black so that way you don't get confused the colors. Let's divide a side by 6 and divide a side by 6. This 6 and this 6 going to cancel out. We're very close to finding sine of beta, right? So all we need to do is isolate sine of beta, actually beta, which was what we're looking for, to tell us, that will tell us what beta is. We're very close to doing that. And what this gonna equal to is sine of beta, which is in green. And I'll probably not switch colors anymore. Sine of beta. The 6 cancels out, as you can see here. 6 cancels out is equal to 8 divided by 6 sine of 35. Now, all of this you can plug it in the calculator. Now, if I plug all of this in the calculator, let me see if I think I can do that in the Google calculator. Let me see. Let me see if they have sine. Actually, I have it. Oh, there you go. My calculator is here. All right, so I do 8 sine, and the first thing you need to do here is make sure that your calculator is in the mode that we have the angle on. And so we have the angle in degree. Your calculator needs to be in degree. If we have pi over 4 or 2 pi over 3 or pi over 6, you would need to put your calculator in radian. Now, in this case, we have the angle in degree, 35 degrees. We need to put the calculator in degrees. And as you probably can see here, which is a little bit small, you'll see the angle. This is marked in degrees. So that means I can move on with this calculation. So it's 8 multiplied by sine of 35 divided by 6. And what do I get? 8 multiplied by sine of 35 divided by 6. And this is what I get for this one. And okay, now we get 0.764768. And I'm going to round the last digit, make that a 6. 764768. And I'll make that a 6. Now, how do we find sine? If we have sine of an angle is equal to some number, how do we find sine? What's the easiest way to do that? What's the easiest way to find sine in this case? So what you would do is say you take the inverse sine of both sides of this equation. So you take the inverse side of this, inverse sine, and I'll put this in a different color so you understand this is not the same. So you'll have the inverse sine. So this is what I had here. Sine of beta is equal to 0.764768. And to find beta, to find the angle beta, let me go in maybe black. I'll take the inverse sine, the arc sine, the inverse sine of this, and also the inverse sine of this. So when you're dealing with math, whatever you do to one side of the equation, you got to do the exact same thing on the other side to keep the equality. And that's what we're going to do here. To keep the equality, I'm going to take the inverse sine of both sides. So this is kind of like, take the sine and then the inverse side. So in this case, in here, you would left with b. And think about this as if you had, 2x, you divide by 2 is similar to this. This is the inverse, so sine of b, and then you take the inverse sine of that. And it's kind of like you had 2x divided by 2 is you left with b. And that's the purpose of taking the inverse side, is to isolate the beta by itself to find the angle. So now I'm going to go to my calculator and I'm going to plug in the inverse sine of 0.76. Actually, that's not what I just put. The inverse sine of 0.768, and that gives me beta is equal to 49.8864. Now, here's the deal. Let's look to see if that looks like a 49-degree angle. According to our pictures, everything should be in proportion. And what I mean by that is a 49-degree angle in the picture should look a lot smaller than a 90-degree angle. Does that make sense? It should look a lot smaller than a 113-degree angle. So now we're going to go back in the picture to see what we had for beta according to the picture, if that's the same thing we have here. Now look at beta. This right here is the angle beta. As you can see here, this looks way bigger than 45 degrees. Actually, it's past the right angle mark, which would be straight. And it passed that. It's a little bit wider than a wide angle. So that means it's at least 90 degrees. Now, did we make a mistake? No, we didn't. So to find beta, the last thing that's left, and that's probably the step that confuses a lot of students. The last step that we have here is to take the supplement of this. So what happened is the equation that you wrote down is, it's this equation. It's going to give you this angle or the supplement of the angle. So now when you look at the picture, you see, okay, it's not obviously doesn't look like a 49-degree angles. All I have to do is take the supplement of this. How do we take the supplement of this? 180 minus this angle. So the beta that we're looking for, let's call it beta prime. What we actually looking for is 180 minus 49.8864. And now I take 180 away from this, and that gives me beta is equal to 130.114. Now, that looks a lot nicer. That looks a lot better. Not nicer necessarily, but it looks a lot better than what we had before, because before we had beta is equal to 49 degrees, and that didn't look like a 49-degree angle. Amber, welcome. So that didn't look like a 49-degree angles. And if we go back and look at the picture, we say that it's a little bit bigger. I mean, it's bigger than 90, it's greater than 90-degree angle, which would be somewhere here. That's straight down here. And 30 degrees, 40 degrees added to that gives you 130 degrees. And I think this looks a little bit better than 49, a lot better actually. So this is how you use the law of sines to find the angle when you don't have them. When you have, two sides and one angle and you want to know the other side. When you have two angles and one side, you want to know all the other sides and angles in the triangle. We could even continue this and use that same formula to find this. So we could even continue it, use that same formula to find this. But the first thing we would need to find is that angle gamma. How do we find the angle gamma? We have this one is 35. We just calculated this one, which is 130.11. And if you guess it, this is, how would you find this? The last one, you would just take 180 minus 35 minus 130.11. Why is that? Because the sum of the angles inside of a triangle needs to add up to 180 degrees. So that would give you gamma, and you can use that in this formula to find the side X, and that would give us all of the other side and angles that we need. Now, any questions? Let me see. Camden, welcome. Colleen, welcome. And yeah, I think this is it, guys. So what I did, how did I get here? The first I did is I know, and that looks a little bit messy now because we didn't start that way. But let's ignore the picture for now. Actually, so what I did to start with, I said, okay, the law of sine says if I have two angles in a side or two sides in the angle, I can find everything else. Let's see if that's true. So the first thing that I did is I said, okay, I have this angle, 35-degree angle, and then they also give me a side that is 8. And they wanted me to find all the other side. They also give me, I think they give me a side also that was 6. They give me these two sides, and then they give me an angle. Now, the law of sine says sine of this angle divided by the side, the length of the side that is directly opposite to that angle, is the same all throughout the triangle. And I'll move on to the next angle. Sine of the next angle divided by the length of the side that is directly opposite to that angle is the same as the sine of the third angle divided by the length of the side that is directly opposite to that angle. And from those, we only needed the relationship between the ones that we have, between the angles and the sides that we had. So we take the angles and the side that we know and find the missing value, which was beta. Now, the last part we had to do is when we get to finding beta, we found that beta was 49 degrees, but clearly in the picture, it didn't look like a 49-degree angle. It looked like something that was a lot bigger than 49 degrees. So now all we had to do is take the supplement of that, which is 180 minus that 49.8864 that we had, and we end up with an angle that was 130 degrees, 0.11. And I think this is it, guys. This is it. If you have any questions, you can ask me here. If you have anything else that you want to talk about too, I'll stick around for a couple minutes and then I will go. Isaac, welcome. Gina, welcome. Chuck, welcome. And guys, if they give you this question for, the only thing I would say watch out for is after you find if they ask you to find the angle, after you find the angle, just make sure that you are using, it looks right by doing the same thing that we just did, going back to the formula, going back to the picture, and see if that's something that makes sense. Because if it didn't, chances are you didn't find it. All right, so guys, I think this is it for tonight. And I hope you have a great one. And thank you for coming and participating as well. And I look forward to seeing you guys in the next session next Tuesday. And no problem. Peace out. I'll see you guys in the next session next Tuesday. And thank you for stopping by. And that was it.